Good morning, everyone. I am here to talk about mashup security and how we can build secure mashups. The work I'm presenting is actually work done by a master's student of ours who is also starting as a researcher in our research group. But before I will dive into details about mashup security, I will try to give an overview of what a mashup really is and how we can reason about mashups and talk about mashups. So, a small example, you have a website, for instance Craigslist here, who has a list of housing opportunities in the neighborhood of Atlanta in the USA, and you have a Google map of the neighborhood. So what you can do basically is you can look up property you're interested in, and you can look up Google Maps to see where it is located. So what does a mashup do? A mashup takes content from multiple origins and combines it into a new service with added value. So in this case, we have housingmaps.com, which is basically a site that takes the Craigslist listings, which are on the right, and the Google map, which is on the left, and puts them together and creates a new service, creating added value. And this is precisely what mashups are about. A mashup can be defined as taking a web application, taking content from multiple sources, even multiple origins, and combining it into something new. And this something new, of course, first of all, it creates added value, but there are other incentives to do the same thing. So what you can do is you can reuse your content in very different ways, which can create very new experiences. Often this content reuse is realized by using content that was not even meant to be reused. For instance, the Craigslist example, when the site was constructed, they were not anticipating that someone would use the content to create something else. A third and very important incentive is the fact that mashups are flexible and lightweight, which allows business users to create mashups from their business data, which also comes from multiple sources, and create new views on specific strategic information. And this business case is quite important and will become more important in the future, since tool support to create business mashups is emerging, and this tool support allows even non-technical users to create mashups in such a way that they can gain some advantage from it. After this short introduction, I will go into much deeper detail about mashups. I will try to list the requirements which are important to create a mashup and to ensure security. Next, I will go into technical details about mashup security and how we can achieve it in multiple ways. And at the end of my presentation, I will try to give a look into the future of mashup security and how things will be evolving. But to do so, to talk about mashup requirements, first another example, which is a bit more elaborate. And in this case, it's a hypothetical financial mashup, which has several components. You have, for instance, an online banking component in the mashup, which provides you access to your online banking information and allows you to do financial transactions. You have a stock advisor component, which can advise you to buy or sell some piece of stock on the stock market. On the left, bottom left, you have the eMart billing component, which is quite interesting because you can, for instance, use it to connect to your local supermarket and see details about the purchases you made there and promotions, stuff like that. And finally, smart advertising is a component responsible to provide ads, but not in an annoying way of stuff you don't need and don't want to buy, but smart in the sense that it can take your user data and decide, oh, this guy is interested in camping stuff, so I will try to sell him some camping stuff using advertisements. To achieve all of this, we need something that creates added value. And in this case, it would be realized or achieved by interaction between the components. So in the advertisement case, if you want to do smart advertising, we need to know what you're interested in. And we can obtain that information by contacting the eMart billing component and asking some details about your purchases. Of course, we want restricted data exposure. We don't want to have the smart advertising know how much money you spent on what item, on which day, in what store, but we want it to know some keywords about some purchases you did in, for instance, the last year. Another requirement to achieve all of this is communication with external parties. Because, of course, mashup components are run on the client side, they're quite lightweight, but they need to retrieve the data from somewhere. So the online banking component will contact the banking backend and ask for data about your savings account, for instance. An interesting case is the advertisement component, which in this hypothetical mashup combines multiple advertisement services, which also means that it needs to be able to retrieve content from multiple sources. And this might become problematic in a mashup scenario, as I will show later on. But this example is the introduction to the requirements. For instance, what if we see that we have the need for interaction, we have the need to restrict that interaction in some sense, and we also want confidentiality, because basically you don't want your online banking information ending up somewhere else. And this brings me to a small list of requirements. Of course, this is not a conclusive list of all mashup requirements, but it's the requirements that are important for the security purpose. So what we have is the need to enable interaction. We want to achieve interaction between components, but on the other hand, we want to restrict this interaction. We don't want any component to talk to any other component without knowing what they're exchanging or what they're doing. On the contrary, we also want to protect the data and code of the components itself. For instance, the online banking component displaying your account information should be protected so that the advertisement component cannot read out its contents, the HTML tags, for instance, and steal your data. That's one very important security requirement. And finally, communication with integrator and providers is essentially the communication with other parties, which should also be possible, even in restricted mashup components, for instance. And in the paper, which will be published later on, we go into details on these requirements. For instance, for the interaction, you don't only want restriction, you also want confidentiality, that your messages are secure. You also want mutual authentication so that you know if a component receives a request that the request was intended for that component, but also where it came from. And as we'll see later in this presentation, this is not always the case. So these requirements are quite conflicting. On the one hand, we have separation, so we have the need to separate components from each other. And we have the need to achieve interaction and communication, which kind of breaks this separation. So finding a good balance is important, and basically ensuring that this balance can be enabled in a secure way is even more important. But before we get to that, a bit about the same origin policy, of which you probably already know, but which is a basic cornerstone of web security. It was meant or created in the time of static applications and with a bit of dynamic nature, but not the dynamic nature found in mashups. And the goal is to separate content from different origins from each other. For instance, to prevent the fact that one component is stealing login credentials from another component or steal information. How does the same origin policy work with mashups? Well, basically, within HTML and the same origin policy, there are two ways to construct or combine content together into one page. There's iframes, which allow you to create a sort of separated frame, separated by the same origin policy, that combines content in the page. Second way are script tags, which allow you to retrieve a JavaScript file from the internet, which can also be from another domain, and include it in the current page. An example of this is, for instance, how Google Maps works currently. What it does is you have a website, you include some API as a JavaScript file from Google, and you can interact with certain function calls to render a map and to display some data points on it. But these two items are insufficient for dynamic mashup applications, because the problem with iframes and scripts is they make you choose between the two extremes. They either offer separation using iframes, but interaction is nearly impossible, or at least very difficult, or they offer interaction basically using script tags, but then you have no separation left. So it's the typical paradigm, the typical contrast between security and usability, or functionality, and that's what we're trying to solve, or what I will be presenting how that can be solved in mashup security. So first of all, one approach is to take the separation offered by the same origin policy, basically using iframes, and to build on that, or to leverage that to create a secure environment for mashups by enabling interaction. There's a list of multiple techniques, of which the first three are basically workarounds. They were invented by mashup developers and exploit loopholes in the same origin policy to enable some kind of cross-domain interaction. Unfortunately, due to time constraints, I cannot explain every technique in detail, but I will focus on the last one, post message, which is the design solution for iframe communication or cross-document communication. Post message enables communication between frames from multiple origins, and it does that by providing a JavaScript API, which is, like the rest of JavaScript APIs, event-driven, to enable this communication. You can exchange messages, and it even provides mutual authentication, which is quite necessary for preventing attacks such as frame phishing. So post message is standardized. It's part of HTML5, so it will be standardized real soon. And on the good side, it's already supported in major browsers, and it's already used today. A quick technical overview of how it works. Sending a message is fairly easy. You have basically you have a frame, and you send it a message using the post message function. You include the message, and you also include the origin, the destination of the message. So your browser will ensure that the frame that receives the message is indeed the intended receiver. So receiving a message, first you register an event listener, and then you have a function handling that event that occurs. And the first step here should be to check the origin of the message. So you can, this is how mutual authentication is achieved. So you specify the destination and you check the origin, and then you know that the communication between the two parties is authenticated, and you can handle the event. A second approach using the separation is not by enabling interaction, but by actually looking at how can the separation be even made more strict. Since we have interaction using post message, but can we achieve strong separation? For instance, can we achieve separation between two documents coming from the same domain? And that's what's done by the techniques listed here. Again, the three first ones are sort of workarounds or propositions for new solutions that are not adopted in all major browsers or in major browsers itself. But the last one, the sandbox attribute, is again a design solution built on the previous ones to achieve this strong separation. The sandbox attribute is an additional attribute to an iframe, so you can strengthen the separation offered by iframes by enforcing that an iframe has a unique origin, and this unique origin allows you to separate multiple components within the same domain. And it also, the sandbox attribute also offers more control over the content. So you can disable plugins, you can disable forms if you want to. You can even disable scripts, all scripts, so which is particularly useful for user-supplied content. If you want to display that and prevent cross-site scripting attacks, you just disable scripting, and you can display the information safely. And you can also prevent navigation from other origins. So again, sandbox attribute is designed and will be standardized as part of HTML5. And at the moment, this is fairly new, and it's not yet supported in major browsers. Only Google Chrome has an implementation of it. But at our research lab, we made an implementation for Firefox, and we also discovered some underspecified behavior in the specification, which is basically left open for developers to fill in. And this underspecified behavior has to do with a unique origin. And what it does, what the problem is that if you have a unique origin, how do you deal with other functionalities such as cookies or communication such as post message or cross-site cross-domain interaction using JavaScript? How can we solve the problem? What is the policy? For instance, if you have a unique origin for a component coming from google.com, do you still want it to have access to the cookies of google.com? Or how does that work? Can it set a cookie? Can it read a cookie? And if you do post message, what is the origin displayed in the event.origin property? Is it google.com or is it some unique random value? So this kind of behavior is left open for our future research possibilities to see what the correct approach is and how this can be either exploited or made even stronger. Technically, using the sandbox in an iframe is fairly easy. Just provide sandbox and you have the basic protection. If you want to loosen specific aspects, you can specify it as options to the attribute. So far for the separation, so what we are going to look at now is how we can leverage the interaction by providing some form of separation between scripts, because we also already have interaction using script inclusion. Can we also provide separation? And this is done, or typically done using subsets of JavaScript, which basically means that you take a subset of JavaScript for which you try to ensure that it is a secure subset and it cannot do